On these problems, we're using the cofunction identity to write an equivalent expression. So that cofunction identity, we have cosine of pi over 2 minus t equals sine of t, and we have sine of pi over 2 minus t equals cosine of t. And that we can derive that from if you had used the difference identity for cosine and sine, you would get these identities. So, but this time we're just applying them, not deriving them. So we're going to look at number 20 and number 24 for our examples. So for number 20, we have sine of 18 degrees. And we want pi over 2, or 90 degrees. So will be equal to cosine of pi over 2 minus 18 degrees, but that's radians and degrees mixed together. So let's convert the pi over 2 to 90 degrees, and we get cosine of 72 degrees. Okay, and then, so that one's pretty straightforward, but let's move on to number 24. That one gets a little trickier because it's got two parts there. So for number 24, at least it's all in radians this time. So I have cosine of pi over 3 plus theta. I want to find the cofunction, so I'm going to change that to sine and take pi minus 2 minus whatever's inside here. So that's pi over 3 plus theta. And I'm using parentheses in there to keep that together because I'm going to need to distribute that negative to the whole thing, because that is the whole thing. That t is that whole thing. Okay, so now distributing that negative, I get sine of pi over 2 minus pi over 3 and minus theta, distributing the negative, which gives me, getting some common denominators, 3 pi over 6 minus 2 pi over 6 minus theta, which gives me pi over, forgot the function, pi over 6 minus theta. That's my final answer. So that's number 20, and that's number 24.